Hello and welcome to Software Architecture course. In this lecture series, we will start with design patterns. In fact, in the next few lectures, we will cover some of the important design patterns and how they are actually used with some examples. Prior to this design pattern series of lectures, we had just completed architectural pattern. And you must have seen that in some of the architectural patterns, I have mentioned in a more informal way what design patterns can be used to implement the architectural pattern. So I did that to basically highlight that design patterns are more fine-grained and more general in nature, and architectural patterns, as we discussed earlier, is more specific. So what are design patterns? So let's look at that. A pattern, well, there is not much of a difference when we say design pattern versus architectural pattern. The basic definition of the pattern and the structure is more or less the same. In case of design pattern, basically it just like architectural pattern, it presents a proven advice. It gives a proven advice in a standard format which can be used in different contexts. Now, a design pattern, as I said, is more specific. Design pattern is not very specific. Design pattern is more generic and more fine-grained, and it gives an advice about a problem in the software design. So there is basically a difference between the architecture and the design. Architecture is at a high level where we deal with basically the components, their interactions, and how they're deployed at a much higher level. And architecture basically becomes a basis for the software design. Now, when it comes to software design, then we primarily deal with, let us say, object-oriented designs. That's quite common in many industrial strength applications. Object-oriented design is the way people actually use for building large software. So these design patterns essentially would be related to object-oriented designs, and it is at the next level of granularity. It is more fine-grained, more specific to implementation. It is not really at the level of architecture. However, for the design patterns, the components are essentially the same, just like our architecture pattern. Well, of course, you have to give a name to it, but then if you recall what we had in architectural pattern, three-part schema. This is the first is context, a situation where it can be applied. Second is a problem, the exact problem that needs to be solved, and fourth one is a solution. That's the heart of the design pattern. Typically, the solutions are outlined in the form of a class diagram, or sometimes in the form of a sequence diagram. Using these two, solutions are kind of presented, very similar to any architectural pattern. So let's look at architectural pattern and design patterns and look at them side by side and look at idioms. So we had definitely revisited that. We have already looked at that earlier. So this time let us focus on the design patterns. Here we have patterns like creation patterns, structural decomposition, organization of work, access control, service variation, service extension, management pattern, adaptation pattern, communication pattern, and resource handling patterns. Now, these are the purpose: to create an object, for structural decomposition, for organizing a work. These are all purpose in a row, and then these are the different patterns that are there. Now in this lecture series we will not cover all of them, but at least cover some important design patterns, and the ones that we're going to cover are indicated in red color. Like for example, we are going to learn factory pattern, we're going to learn composite pattern, we're going to learn command pattern, proxy pattern, and so on. Then on the right hand side we have idioms, which are even more fine-grained. We discussed that earlier. So idioms are more specific to a programming language, like singleton, factory methods. These will be more tightly coupled with the programming language. We will cover at least singleton and factory method in this lecture series. Now these patterns that we just saw, they can be broadly categorized into three buckets: creational, structural, and behavioral. And our lecture series would be organized in this manner. We will first cover creational patterns, then we will cover structural pattern, then we are going to cover behavioral patterns. So these three structures or three classifications, creational, structural, and behavioral, this classification is done by the inventors of popular design patterns, who are called Gang of Four, or GOF shortly, in a short form. So GOF, or Gang of Four, so four people basically have created these classification. So factory pattern, factory method, singleton are the three patterns which are related to creation of objects. Adapter, composite, decorator, proxy, these are about structure. And on the right hand side here in this particular column, I have basically I have already put the purpose. So the purpose is something that we just now saw in the previous slide. So essentially adapter and composite, for example, are structural pattern, and the purpose is for structural decomposition. Decorator pattern is also a structural pattern, but the purpose would be service extension. Now proxy and iterator are, proxy is a structural pattern and iterator is a behavioral pattern, but the purpose of proxy and iterator are same. It is about access control. Observer pattern is a behavioral pattern. The purpose is communication. Visitor is about, again, service extension. So the decorator is service extension, as well as visitor is also about service extension, but one is structural and another is behavioral. Strategy pattern is about different variation of a given service, and command pattern is organization of work or organization of task. So let's look at the creational pattern. What is a creational pattern? It essentially provides mechanism to create objects in a more generic manner. So why do we need a creational pattern? We need it because a direct object creation sometimes creates a problem. Essentially, sometimes it can make the application more vulnerable to frequent changes. So what's meant by that is that if an application is directly implementing, or application is directly creating an object, and that object structure goes for various changes, then sometimes the application which is creating an object might be impacted. So the application just is trying to create an object of a particular class, and that class is undergoing frequent changes, then that change might impact this application. In order to shield that, there is a creational pattern which is basically sits in between the application and an object that's being created. So this class which sits in the middle basically controls the object creation. So in that sense, a creational pattern is more an indirect way of object creation. So the purpose is that it provides different ways to remove explicit references in the concrete classes from the code that needs to instantiate them. So essentially, the code that requires a particular object to be instantiated, in that code, if you put an explicit reference to the concrete class, then it becomes again quite inflexible, in a sense that if tomorrow I want to change the concrete class to another concrete class, and I want the code, which is a user, to use a new concrete class, it becomes difficult if there is an explicit reference. But if there is a indirect reference, then it is possible to change the concrete class, and the code that is using this concrete class need not know and then need not be modified. So it might sound bit complex, but we will study these patterns and you will see that it's not that difficult. It's actually quite easy. It's quite simple. The idea is quite simple. So, but before that, let's still continue with creational patterns and its motivations. So the whole purpose is a system should be independent of how its objects and products are actually created. If it is independent, then the system becomes more reusable. So how it is done, the basic idea is that hide the implementation of a class, library, or a product. Basically just reveal the interfaces. Through the interface, let the system interact. Therefore, if someone creates different representation of independent complex objects, that really shouldn't impact the main system. Very important that the main system shouldn't be impacted if I choose to change the representation of the complex object that the system is using. There could be another reason why we need a creational pattern. So a class might want its subclass to implement the object it creates. If the class does not want to create an object directly. The class instantiation need to be specified at runtime. So this is a very important statement. The class instantiation are specified at runtime. That means that during compile time, such instantiation is not specified, meaning in the code, the program that you write, in that program, the instantiation of a class, meaning that creating a new object of a class, that's not specified directly. That happens at runtime. And if that can happen at runtime, then basically the code becomes portable and much more generic. There could be another requirement that I need to have only a single instance and the client can access this instance all the time. I don't want multiple instances to be created. I may also want that an instance should be extensible. I should be able to extend an instance and I don't want to modify the code. So these are all different requirements for which a creational pattern might be required. So let's look at three important creational patterns. A factory method pattern, essentially it's a method that creates a type of object and it centralizes the creation of objects. Inside this method, the creation logic is there. Factory pattern centralizes the decision of what factory or the class which essentially creates a business object to instantiate. There is a slight difference between factory pattern and factory method. Factory method is a method. Factory pattern is essentially a class. So in both the cases, this centralization happened, but in the factory pattern it's a class, in the factory method it's a method. Singleton is a pattern which restricts instantiation of only one object or only a set of objects which is controlled for our business logic. It does not allow anybody to create objects. So it completely restricts that. So let's start with the factory method pattern. So the context here is a type or the creator basically creates objects of another type or the product. So there is a type called creator, there is another type called the product. So a creator basically creates a product. Now subclasses of the creator may need to create different kinds of products, and the end client do not really need to know the exact type of the product object. So here the solution is that define an abstract creator type that contains the main logic of handling an abstract product. So there is an abstract creator type that contains the logic of handling an abstract product, and define an abstract method called the factory method in the creator type. So this factory method essentially yields a product object. Now each concrete creator class, remember creator is basically an abstract, so therefore this abstract creator cannot be really used in any meaningful way. If you have to create an object of this creator, you need to have a concrete class. So this concrete class is basically a subclass of this abstract creator class that is going to implement the factory method. Remember, in the creator type, this factory method is an abstract method, means it has got no implementation. So this concrete creator implements the factory method and it actually returns an object of a concrete product. Now side by side you create an abstract product type that models a common product, or the notion of what is a product. It basically models that, and then create concrete products which can be instantiated. So essentially each concrete creator creates a concrete product. Let's look at the class diagram to understand this in more detail. And for that, let us look at an example. So suppose you want to create a document management framework, and this framework essentially it knows when to create an object. Imagine that you are creating a framework in which it's a GUI application in which you are giving a facility to create a document. So it knows when to create a document, meaning that it is a client or the end user who is going to decide when this document needs to be created. So it knows when to create a document. When the user basically selects a menu item, at that point in time it needs to be created. But this document management framework does not anticipate what type of document the user is going to choose and create. So let us look at this factory method and let us see how it works. So on the right hand side, this document management framework or the abstract creator class is there, in which it has a method called create document. This is basically a document. This is basically a method that is supposed to create a document, but in this particular class there is no implementation of this method. So this is an abstract method. Create document is an abstract method. Plus there are other methods like new document, open, save, close. So these methods are possibly implemented in this document management framework class. For example, in the new document method, you see what happens. So public void new document. Note that here I am using a Java style, a Java type programming. It's not necessary that it has to be Java. You can use C++ also. The pattern would remain the same. So let's look at this public new a public void new doc, document D equal to create document. So this create document is nothing but this particular abstract method. Document D is create document. So look here that this particular method really does not know what is this document type. Now then in the document list this D is added and then D is opened. Now let's look at the abstract product, which is the document class, and this document has this document class has methods like open, save, protect, close, and so on. Now then look at these concrete classes which are below this abstract class. So I create a document called HTML document. HTML document. This is a concrete class that inherits this. It inherits from this document object, and it basically returns a new HTML document. It is basically a new if someone does new HTML document, then what is created is basically a HTML document. Now look at the class which is on the right, HTML doc creator. This is also a concrete class, but this is a class that has been inherited the method create document. In fact, it's a subclass of document management framework class. It's a concrete class, and it has implemented create document method, which was abstract here. Now inside the body of this create document, what it does is it basically creates a new HTML document and then returns a HTML document type object. So if someone invokes new document on HTML document creator, if someone invokes this method new doc on this, then essentially this HTML document will be created and it will be added in the list. So the beauty is that the one that's at the top, this is basically the framework. This is what is created, and is created, possibly it is created as a library, and it is given to the people. Now the people are now freely creating PDF document, HTML document creator, PDF document creator, and they are able to open, new, save, close, etc. So, and one can add more and more document types, but those document types creation would not really impact the framework. So the whole purpose of the the pattern is to basically build such a framework like this, and you will see such examples more in other patterns. So HTML doc creator basically creates a HTML document. Let's look at the example of PDF doc creator. PDF doc creator also creates a PDF document like this one. This PDF document is a subclass of document. Now in the create document method of PDF creator, it does an extra thing. So it basically checks whether the PDF library is actually installed in the computer. If it is installed, only then it is created, otherwise it might throw an exception, it might throw an error. So it does an additional work. In the HTML document creator, it might just simply create an document, create an object of type HTML document and just return the handle. However, in the PDF doc creator, it might do some additional work. So I purposefully shown these two, and here I showed two steps to show that you can have your own creation logic, and that can vary from one concrete class to another concrete class. Let's continue with the example. So as I said earlier, these framework classes are all abstract, and it does not really change when a new document types are added. So it becomes a fixed library. Document management framework class can also provide a default creation of a document, and that's generally a good programming style in many cases. So client keeps supplying new types of document and new types of document creation factory, and as it is supplied, it can nicely fit into this framework classes. Document management framework is not really getting changed. It is fixed. It won't be impacted. So the benefits are, it clearly introduces a separation between the application and the family of classes. It clearly creates a separation. It basically creates a weak coupling instead of a tight coupling, and weak coupling is a good design practice for any modifiable code. If you are building a large application, you should always focus on making the coupling weak and cohesion strong. So here weak coupling is used instead of tight coupling. It hides concrete classes from the application framework. It's a very simple way to extend the family of products with minor changes in the application code. Plus it provides the customization hooks. One example I showed, that PDF creation. So from factory method, let's look at abstract factory pattern. Kind of similar, but not exactly the same. Here the context is, instead of one product, like the example of HTML document and PDF document, there could be multiple families of products which needs to be instantiated, and system need to be independent from the way the products are created, plus the product are used after creation. So essentially the system or the framework must be independent from the way the product it works with what they are created. So the solution is that create a factory to instantiate objects specific to a particular family of product. So here a factory creates a family of products, a family of meaningful products. Here there will be one factory class per product family. Let's look at this example. Here we are talking about GUI factory, and this GUI factory is here. This GUI factory is used by my application. So my application is essentially a GUI application. I am going to create my own GUI. I am going to use this facility, which is a GUI factory. So let's look at how this factory pattern works here. So there are two concrete factories, Windows GUI factory and OS X GUI factory. This GUI factory pattern essentially has methods to create button, method to create an edit box, or method to create a field. So it returns a button, edit box, or a field. And now there is a Windows GUI factory. This is a family. So this Windows GUI factory can create a Windows button, or it can create a Windows edit box, or it can create a Windows field. So I have not shown the Windows field link because then the picture will be a bit clumsy, but I'm sure you get the idea. So it will create a Windows button, Windows edit box, and it will create Windows field. So what are these Windows button, edit box, and field? These are again an implementation of the abstract class or an interface called button, edit box, or field. So in your actual design you can either use an abstract class or you can use an interface, doesn't matter. So in this example I have shown interface. So there is an abstract interface, or well, interfaces are all abstract. So there is an interface called button, and there is a concrete class Windows button that implements this button interface. and this Windows button is created by Windows GUI Factory. Let's look at the OS X GUI Factory. This OS X GUI Factory creates OS X type button, OS X type edit box, and OS X type field. Now OS X, as you know, it's for Mac operating system, and Windows is for Microsoft Windows. So each style, Windows versus Mac OS, basically defines different look and behavior for each type of controls, like buttons, edit boxes, or fields. So the look and feel or the behavior of these buttons would be different if you shift from Windows to OS X. Now, where do you put this logic of this different look and feel plus different behavior? So in order to really make the whole system generic and extensible without any hard coding, this abstract class GUI Factory is created, and then there are different types of GUI Factory. In my application, suppose I want my application to run on both Windows as well as OS X. Now I can choose the OS and then I can run my program, and depending on that configuration parameter, my app possibly chooses one of the concrete factories, either a Windows GUI Factory or a OS X GUI Factory. Now once that's chosen, then that particular factory will create the necessary products like Windows type button or Windows type edit box or Windows type field. Essentially, this button creation request or edit box creation request, these are delegated to the concrete factory. So this is what is basically the abstract factory pattern. With this we conclude. We'll continue with other design patterns in the next class.